Hey guys, example 3. Okay, so a 250 kilogram box slides down a ramp and then across a level floor. The coefficient of kinetic friction between the box and the floor is 0.200. A person sees the box moving 1 meter per second left and then pushes on it with a momentary horizontal force of 140 newtons to the right for whatever reason. A, how far does the box travel before coming to a rest? B, how will the results change if the box is instead moving right and the person still pushes right with the same force? Calculate for proof. So, a good idea to get in the habit of is if they're not giving you a diagram in the picture, draw your own diagram. So it was moving to the left, so I drew the ramp over here. The box is moving down. Then the time that we're dealing with here is the flat surface. And the person, eyeball here, sees it moving a 1 meter per second to the left. And they apply a force, this gigantic arrow here, of 140 newtons to the right. So let's figure out what the heck it is we're trying to find using our grass method. So given, we have our mass, 250.0 kilograms. We have coefficient of kinetic friction, mu k, 0.200. V1 is 1.00 meters per second left. V2 is given in the question, 0 meters per second. An applied force is given, 140.0 newtons to the right. And I think that's it. So now what we're looking for is how far does it travel. That's delta D. So I got V1, V2, delta D, and I know in my kinematics equations I'm gonna likely need A. And A connects well with the forces. So we're going to use the forces to figure out A. So let's draw a free body diagram. So if it's moving to the left, then the kinetic friction is to the right. But I also have this applied force to the right. Okay? So my net force equation looks like this. And we'll say that the net force is to the right. We'll say that right is positive. Because most of my forces are acting in that direction, so I'm going to say that that way is positive. So F net is the same as FA plus FK, and that's equal to MA. What don't I have here? I don't have A, so I'm going to rearrange this for A. FA is a number. FK is mu k Fn. So FA plus mu k Fn is the same as Fg, as usual, which is the same as mg. So now I can just plug in my numbers. And solve for A. And I get 2.52 meters per second squared. So now that I have A, I have A, V1, V2, and I can use delta, I can find delta D. I have this equation from before. Yes, it's coming back to haunt you. But don't worry, you'll be getting all your equations on the test as usual, including Unit 1 equations. So rearrange this for delta D. I get V2 squared minus V1 squared over 2A. Now be careful here because when you sub in numbers, my acceleration came out positive, which means my acceleration is to the right, right? But my initial velocity is to the left. Okay, so 0 in for V2 minus, we'll say that right is still positive, so this is going to go in as negative. And I'm going to get 1. So I'm going to get negative 0.198 meters, or 19.8 centimeters to the right. So the box travels that far before coming to a stop. How will the results change if the box is instead moving to the right and the person still pushes to the right with the same force? Okay, well that's a whole different question because now for part B, we're going to have to draw a new free body diagram. If the box is moving to the right, then kinetic friction is to the left, and the applied force is to the right still. So all that's going to change is the distance or the displacement and the acceleration. So let's find the acceleration again. So FA is positive now, FK is negative. Plugging in your formulas as before and your numbers. Oh, I don't think you can see this. I'm so sorry. There you go. So same as before, but now our FA and FK are in different directions. So our net force equation looks slightly different, but all of our numbers and stuff are going in the same, and our result's going to be different. So when I calculate that, I'm going to get an acceleration of negative 1.40 meters per second squared. That means my acceleration is to the left. So it actually means the kinetic friction is greater than the applied force. So let's figure out our delta D now. 0 take away 1 all over negative 1, sorry. We're still saying that right is positive, so we're going to put in that negative acceleration. Negative over negative is positive, 0.357 meters, or 5.7 centimeters to the right. So in this case, the box is going to travel 37.7 centimeters to the right. Does this make sense? Let's go back. In this situation, the box was moving to the left. All the forces applied to them were to the right, and the box ended up moving to the right a little bit. In this example here, the applied force was to the right and the kinetic force was to the left, but we were moving to the right. And it was moving to the right and the applied force was to the right, so it makes sense that the box would move a greater distance as calculated there. Alright, so if you're keen, I've already done solutions to all these problems here. It took me about 7 pages and an hour and a half, so hopefully you have some time in class to work on these and a homework. You're also getting a work period for review next week, but you have a while to work through these questions and ask me questions, and we can take them up. So do your best and let me know how it goes. Thanks. Bye.